I'm gonna serve the 135 candy. I already explained this problem in my previous video. So I'm gonna explain another solution in this video. I'm gonna skip the explanation on this problem. In my previous video, I introduced the solution using sorting algorithm to allocate candies according to the rating values in ascending order. To do that, I used the index and the value pair table to sort by the rating values. This is the solution code that I explained in my previous video. This code performs analog and time complexity due to the sorting algorithm. I'm going to introduce another solution which is close to and time complexity. Okay, let's see the idea. There is a ratings array here. We can start to allocate candies with 0 ratings, and then we can expand the allocation to each neighbors. We can also expand the allocations to each neighbors in the right side. This is the similar behavior to my previous solution using the sorted rating and its index pair array. But can we do this without sorting ratings array? I'd like to do this chaining behavior without sorting the ratings array. I came up with a BFS algorithm using queue operation. So at the beginning, 0 ratings will be queued as a starting point of BFS algorithm. And when it is dequeued, we have to check its left side and the right side. This is the basic concept to update the candy count expanding area. Let's simulate the BFS algorithm step by step to allocate candies. Candy count for children will be initialized as 0 at the beginning. And at the beginning, the lowest ratings will be queued as a starting point. And when it is popped from the queue, it will be allocated a candy as one considering its neighbor values. And then its neighbors will be queued, and the second 0 rating will be popped, allocating candy as 1. And also its neighbors will be queued, and the number 3 is popped, and allocate candy as 2, considering its neighbor in right side. And then the number 4 is popped. We can allocate candy as 2, considering its left side neighbor. In the next, number 5 is popped, and 2 candies are allocated. Lastly, the number 6 is popped. We should allocate 2 candies. It seems working properly, but there is a problem in this process. Number 4 and 5 are not properly allocated candies. There is a problem in the allocation of number 4. It should have 3 candies, bigger than number 5. Why is this happening? It's because when the number 4 is popped, number 5 had 0 candy. At the moment the number 4 is allocated 2 candies, and then the number 5 has been changed to number 2. So at this moment, we have to update number 4 once again by enqueuing. So the number 4 is popped again, and it can be allocated 3 candies. So at this time we have to check its neighbors. This is the main idea of BFS algorithm. Let's see the solution code. The solution is composed of 2 parts. At first it tries to find mean values in its ratings array to use them as the starting point of BFS algorithm. After queuing items, we should set the queued flag true for its item index. This flag is used to prevent same items queued twice by its neighbors in both sides. This makes the calculation difficult, so we have to prevent this behavior using queued flag for each items. Okay, let's see the while loop. The queued item is popped sequentially, and also setting the queued flag false, and calculate the candy count considering its left neighbor and its right neighbor respectively, and choose the bigger one as its candies, and the count is added on some variable. This is the condition to do its training behavior by checking if the requirement conditions are not satisfied. If in that case, we should enqueue its neighbor item one more time to update its candies. In that case, we have to subtract its current candy count from the sum variable because it will be added again when popped from the queue with its updated candy numbers. If the current candy number is 0, which is the initialized value, we just set as 1. Actually, this code is unnecessary because when this item is popped, the number of candy is calculated. The same behavior is performed for its neighbor in right side. And finally return the sum variable. Okay, this code performs 20 milliseconds, which is the same as the previous solution. But I realized that this code has a weak point. It could encounter the time limit exceed when it means the worst case input data arrangement like this. If the starting point is 0 index, it could have n squared time complexity by moving toward the right side. In that case, it should always update its past data and its left side of current updating point, so it will have n squared time complexity. But I added the code finding the smallest rating point that prevented the time limit exceed. But we can manipulate the input data arranged as the worst case from the starting point of minimum rating. In that case, this algorithm cannot avoid time limit exceed. So normally this code is close to n time complexity, but it could be much slower in the worst case with input data like this. Okay, thank you for watching. See you next time. Bye bye.